All right, let's talk about AI and games. We're going to dive into how researchers are trying to build AI that can absolutely conquer games, not in just one way, but through two totally different and, frankly, epic quests.
So this is the big question, right? How do you actually build an AI that's a beast at playing games? Because the way researchers are trying to answer this is pushing the whole field of artificial intelligence forward in some really cool ways.
You see, it really splits into two main paths. On one side, you've got the quest for what we'll call the Grandmaster, an AI designed to solve a single, ridiculously complex game. And on the other side, there's the Universal Player, an AI that can learn the rules to basically any game you throw at it. Let's break them both down.
Okay, first up, the Grandmaster. This quest is all about specialization. It's about taking one game, a game specifically created to be a complete nightmare for computers, and then just solving it with raw, brute force computational power.
And the game they're targeting is called Sprouts. It looks super innocent. You start with some dots, and you just take turns connecting them with lines, adding a new dot on the line you just drew. The last person who can make a move wins. Sounds simple, right? Yeah, not so much.
Now this is what I think is just wild. We all think of chess and Go as the peak of strategic complexity, you know? But look at Sprouts. The number of possible moves, its game tree complexity, isn't just bigger, it's astronomically larger. This game was literally designed to be hard for computers.
So to crack this thing, researchers had to invent a whole new weapon. They came up with this crazy algorithm that could wrangle over 1,000 computer cores, all working in perfect sync to search through all the game's possibilities at an insane speed.
And this number really shows you how well it worked. This new method was over 332 times faster than older approaches. That's not just a small improvement, that is a massive, revolutionary leap forward.
And the results were just staggering. I mean, we're talking 10,000 times faster than the previous best solver. It was generating proofs 1,000 times more complex. This wasn't just about winning a game. It nearly doubled what we know about Sprouts, and even helped prove a math conjecture that had been sitting around for decades. That is the incredible power of the Grandmaster approach.
All right, so let's shift gears and look at the second quest. This one builds a totally different kind of intelligence. It's not about going super deep, it's about going super broad. The goal here is to create the Universal Player.
Now, the problem with these universal AIs has always been that they're kind of a jack of all trades, but a master of none. If you can play any game, it usually means you're kind of slow and clunky at every game. A new system called Regular Games, or RG, is trying to fix this. It represents game rules using a simple, super efficient structure. Think of it like creating a universal flowchart for any game's rules that a computer can read and understand incredibly fast. And it's not just a language, it's the whole shebang. It's a full ecosystem. Game designers can write rules in a simple, high-level language. A compiler then crunches those rules down into this hyper-optimized C++ engine that an AI can just plug into and start playing right away.
And they didn't stop there. They built a whole suite of modern developer tools, like a slick code editor and visualizers, which makes it super easy for anyone to design new games and actually see how the AI is understanding the rules. So, this all sounds amazing, but here's the real question. Is it actually fast? Does this universal approach finally get over that performance hurdle?
Well, the numbers kind of speak for themselves, don't they? This table shows how many game simulations or playouts each system can run per second. Just look at Connect 4. RG is doing over 1.2 million playouts a second, while another leading system is at about 55,000. It's a massive difference across the board.
On average, the regular game system was 10 to 20 times faster. It basically achieved the holy grail here. It's both universal and incredibly efficient. And that kind of speed means the AI can learn faster, test more strategies, and just become a way stronger player at any new game it sees. Okay, so this brings us right back to our two quests. You've got the specialist AI that can solve impossible problems, and you've got the generalist AI that can play anything. So, which one is the better approach? Which quest is winning? But it turns out, thinking about this as a competition, specialist versus generalist, is completely the wrong way to look at it. They're not actually rivals. They're two sides of the exact same coin, and they're both pushing AI forward.
So let's zoom out and look at the big picture, because this has always been about more than just winning games. Games are the perfect laboratory for building different kinds of intelligence that we can then use to solve real-world problems. The Grandmaster, the specialist AI, shows us how to build tools that can tackle these super deep, intricate problems with overwhelming computer power. The universal player, the generalist AI, on the other hand, teaches us how to build systems that are flexible, adaptable, and can learn new things on the fly.
So, what does this actually mean for us? Well, the specialist approach could lead to huge breakthroughs in really complex fields, like discovering new medicines or proving mathematical theorems. But the generalist approach, that could give us things like robots that can adapt to new jobs on a factory line, or personal assistants that can actually learn our unique habits.
So you see, both quests are absolutely vital. They're pushing AI in equally important directions. It really just makes you wonder what incredible things are going to be possible when we finally figure out how to bring the deep power of the Grandmaster together with the flexible mind of the universal player.